These are notes from Math 60, Wednesday, April the 1st, 7.2, page 604 in Melham's class. This material will not be on Friday's exam, April the 3rd. The exam is just for chapter 6. So we're just getting ahead a little bit. And once again, everything is on one sheet of paper here. If it's a little bit unreadable or too small, remember that you can print this out and have it full size in front of you. So as I go through everything here and point things out, rather than looking right here, just listen to the audio and follow along with your full size sheet, hopefully from what you have. And again, I'll be going somewhat fast to make the video as short as possible. If I'm going too fast, remember that you can always rewind or fast forward as often as you wish. Problem 29 on 7.2, page 604. 4x to the fourth raised to the 1/2 power. This section we're getting fractional exponents, right? So we recall one property of exponents is I can distribute the 1/2 onto the 4 to the 1/2, and the 1/2 onto the x to the fourth. And you might recall if you have a power followed by another power, you can multiply these powers. 4 times 1/2 is just 2. So this is x squared. And I now have 4 to the 1/2 power. 4 to the 1/2 power, the number on the top means a power or an exponent. The number on the bottom is a root. So power over root, which means 4 to the first power, which is just 4. And the 2 means the square root. So 4 to the 1/2 is the same as the square root of 4. So what that means is that if you raise any expression to the 1/2 power, it means the same thing as square root, because you're taking an exponent of 1, which means you don't do anything to the number, and you're taking a square root. So square root of 4 times x squared, and the square root of 4 is just 2. So the final answer is 2x squared. Problem 33, once again, if you temporarily ignore all of this stuff and just realize you have something raised to the 1/2 power, it means take the square root of that whole mess. So we're taking the square root of negative 64 p to the 8th power. Well, we cannot take the square root of negative 64, at least right now we can't. So we're just going to say not real. Later on in this semester, we actually will deal with square roots of negative numbers. They're going to lead to something called imaginary numbers and complex numbers, but we're not quite there yet. 35, negative 27 n to the 9th raised to the 1/3. That's an n, sorry. So if I raise something to the 1/3 power, again, the number on top is a power. The number on the bottom is a root. So power over root. If you need a little memory trick, I remember the root of a tree or the root of a plant is always down. So this is a root and this is a power. So I raise this expression to the first power, which means don't do anything to it, and then take a cube root to 3. So it's the same thing as the cube root of negative 27 n to the 9th. Okay, so quick summary, if you raise something to the 1/2 power, it's the same thing as square root. If you raise something to the 1/3 power, it means the same thing as cube root. So I want the cube root of negative 27 n to the 9th. The cube root of negative 27 is negative 3, because negative 3 cubed, negative 3 times negative 3 times negative 3 is negative 27. And the cube root of n to the 9th is n cubed, because n cubed n cubed times n cubed times n cubed comes out to be n to the 9th. So our answer is negative 3n cubed. 39, you have x plus 1 to the 6th raised to the 1/6 power. And I'm changing the problem a little bit. I'm not going to allow for, in the text, they go over absolute value and having to worry about whether you have a positive expression or non-negative expression. I'm not going to worry about that right now. I'll just simply go 6 times 1/6 is 1. So x plus 1 to the first power, which is just x plus 1. If you're looking in the book, what they have is actually not wrong. It's correct, but I decided to forgo that and not worry about that right now. So we're just assuming that x plus 1 is a non-negative quantity, positive quantity. And if that's bothersome to you, don't worry about it. We'll just go with x plus 1. Problem 41, 36 to the 3/2 power. So once again, the 3 represents the power. The 2 is the root. So I'm taking the square root. Notice I put the 2 in parentheses. You don't really have to put that 2 there, but just to illustrate, you might be wondering, where does that 2 end up? That 2 goes here. But we know that if there's a 2 here, you normally just don't put it. So you could just simply write the square root of 36 and just leave that out. Square root of 36 and then cube it. The square root of 36 is 6, and then 6 cubed. 6 times 6 times 6, you don't have to memorize that. You can punch it in your calculator. That comes out to be 216. A side note, in case you're wondering, could I cube first, take 36 to the 3rd power, cube it, and then take the square root? Technically, yes, but that is usually harder to do. If I take 36 to the third power, that's 36 times 36 times 36, which is a much larger number. I would need to get a calculator for that. And then take that big number and then take the square root. You would get the same answer, but normally it's easier for these kind of problems to take the root first. That gives you a smaller number, and then go ahead and raise to the third power afterwards, rather than doing the power first. That usually gives you a much bigger number, and then followed by the square root. That's usually a little bit harder. 45. Negative 1 over 216 to the 2/3 power. Once again, the 2 is an exponent, the 3 is the root. So I take a negative 1 over 216, I want the cube root, and I follow it up with a square. The cube root of negative 1 over 216 is actually negative 1/6. Negative 1/6 cubed, negative 1/6 times negative 1/6 times negative 1/6 is negative 1 over 216. So this expression right here is the same as negative 1/6. And then I square it. So negative 1/6 squared is a positive 1 over 36, because I got negative 1/6 times a negative 1/6 is a positive 1 over 36. Back up here for 49. 25x to the fourth raised to the 3/2. Once again, the 2 means the root, and I put the 2 in parentheses, meaning you don't really have to write it. You should normally just write it as square root of 25x to the fourth. And then the 3 means the exponent. So once again, for a fractional exponent, it's power over root, or you can say exponent over root. The way I memorize it is the root of a plant or the root of a tree is further down. So that's the down part. So the square root of 25x to the fourth, the square root of 25 is 5. The square root of x to the fourth is x squared. In other words, 5x squared is the object by which if you square it, you get back 25x to the fourth. Now I cubed the whole thing. So it's 5 cubed, 5 times 5 times 5. You can use a calculator if you wish, 125. And then x squared cubed, we have a shortcut that says if you have an exponent here and then another exponent here, you can just multiply the two, x to the 6. Or again, you can appeal to the definition. X squared cubed means x squared times x squared times x squared. And so you have x to the 2 plus 2 plus 2, x to the 6. 53. 81 x to the fourth y to the eighth raised to the 3/4 power. So the 4 means the fourth root. So I'm taking the fourth root of this whole mess. And after I get that answer, I raise it to the third power, because that's the number on the top. So the fourth root of 81 is actually a nice number. It's 3, because 3 to the fourth power is 81. And the fourth root of x to the fourth is just x. And the fourth root of y to the eighth is y squared. In other words, this quantity right here, the 3x to the fourth y squared, that's the object by which if I raise that to the fourth power, I get back 81 x to the fourth y to the eighth. And now I'm supposed to cube that expression, which means I cube everything. I cube the 3, 27. I cube the x cubed. And y squared cubed is y to the 6th. 57 just says write as an exponent 8abc. So we know the root is 5. I don't see any power, so you pretend it's a 1. So it's the same as 8abc raised to the 1/5 power. 61, they want you to go the other way. 6x cubed y raised to the 1/4. The power is 1. The root is 4. So I put the fourth root. And the exponent is 1, which means you can just ignore it. So fourth root 6x cubed y. 65, 4 to the negative a half. You might recall a negative exponent means put the expression into the denominator and make it a positive exponent. So 1 over 4 to the half. And we've previously mentioned that if you raise something to the 1/2 power, it means the same thing as square root. This is the root, 2. The power is 1, which means just leave it alone. So it's 1 over square root of 4. And so that leaves us as 1/2. For 71, you might recall if you have a negative exponent and the base is a fraction, you can invert the fraction. Instead of negative 27 or 8, flip it to negative 8 over 27 and raise it to the positive 4/3. Okay, so again, if you have a negative exponent, change it to a positive exponent and invert the fraction. Now I play the same game of having this as the root and this is the power. So I do the cube root followed by the fourth power, root power. Cube root of negative 8 over 27, it's a nice number, it's negative 2/3. What number cubed gives me negative 8? That's negative 2. What number cubed gives me 27? That's 3. And so now I take the negative 2/3 and raise it to the 4th power. It'll be a positive because a negative to the 4th power, negative times negative times negative times negative is positive. 2 to the 4th, 2 times 2 times 2 times 2 is 16. 3 to the 4th, 3 times 3 times 3 times 3 is 81. The answer is the fraction 16 over 81. Up here for 75, 1 over 9 to the negative 5/5. If you have a negative exponent in the denominator, you can bring it up into the numerator, which means there's nothing left in the denominator, so I don't have to write divided by anything. It's just 9 raised to the positive 5/2. So once again, the 2 means a square root, so I put a 2 in parentheses here just to emphasize that that 2 matches that 2, but in reality you don't have to write it. It's just square root of 9. And then you raise it to the 5th power. Square root of 9 is 3. 3 to the 5th power, you can just punch it in your calculator. 3 times 3 times 3 times 3 times 3 comes out to be 243. 79, 6 to the negative 2/3, 6 to the negative 4/3. Well, we do have the same base here, so we have a root from before that says I can just add these exponents. So negative 2/3 and a negative 4/3 makes 6 to the negative 6/3. But negative 6/3 is the same as negative 2. So I have 6 raised to the negative 2. The negative exponent means I can drop the expression to the denominator and put 1 over 6 squared, and 6 squared is 36, so my final answer is 1 over 36. 83, all I have to do is distribute the 3/2 onto this, 3/2 onto this. We just multiply the exponent, so a to the 1/2 times 3/2 is 3/4. B to the 1/3 times 3 over 2, if I multiply these two, the 3's cancel out, so I just have b to the 1/2, and you can just leave it like that. 87, a to the 3/4, a to the 3/4 divided by a to the 1/2. On top, the numerator, I can just add these exponents, so a to the 3/4 plus 3/4 is 6/4. Well, 6/4 reduces to 3 over 2, so I have a to the 3/2 divided by a to the 1/2. And so I have a rule that says I can subtract these exponents. So 3 over 2 subtract 1 over 2 is 2 over 2. So a to the 2 over 2 is the same as a over 1. But if it's a to the 1, you can just leave your answer as a. In fact, I should be stronger. You should leave your answer as just a, not a to the 1st power. Then 89 over here, it's just a distributive property. You have y to the 1/3 times y to the 2/3 plus y to the 5/3. So I distribute this times this, this times this. So I add exponents, 1/3 plus 2/3 is 3/3. 1/3 plus 5/3 is 6/3. But y to the 3/3 is the same as y to the 1, and if it's y to the 1, just write it as y. And y to the 6 over 3 reduces to y squared. 93, the 4th root of 5 squared, they want you to simplify it and write it as a radical. Well, this is the power, and this is the root, so we write it as a fractional exponent, power over root, so it's 5 to the 2/4. Power over root, 2 over 4. 2/4 reduces to 1/2, so it's the same as 5 to the 1/2, but we've already seen that raising anything to the 1/2 power just means a square root. So it's a square root of 5. Okay? Or if you want to go literally by what's going on here, this is the power, and this is the root. So square root, raised to the 1st power, but if you raise to the 1st power, you don't do anything, so just leave it alone. Finally, for 95, same kind of game. 9th root of 11 cubed, write it as a fractional exponent. So the fraction is 3 over 9. This is the power. Power's on top, root on the bottom. So it's 11 to the 3 over 9. 3 over 9 reduces to 1/3. So I have 11 to the 1/3, and we've previously seen that this means cube root way back over here, right? If I raise something to the 1/3 power, this is the power, which is 1, which means don't do anything, and 3 is the root, so it's a cube root. So I just put the cube root of 11. So these are the notes for Math 60, Wednesday, April the 1st for 7.2, page 604. Again, this material will not be on this coming Friday's test. It'll be on the next test.